Hey Algebra 1, today we're starting Chapter 6, and in Chapter 6 we're going to be factoring a lot. But one of the biggest reasons why we learn to factor is to solve equations that we normally wouldn't be able to solve just by trying to get x by itself. So if you would, let me show you an example of what I'm talking about. If we have x squared plus x equal to 5. If we're looking at that, and I just made that up real quick, but you can see how it's a polynomial, right? So I don't know, maybe to make it a little easier, I'll make it a 5x. So now we got a polynomial and a monomial here, a binomial and a monomial. Well, to try to solve this by getting x by itself would be an exercise in futility to an extent, because you have multiple x's. Now you could get these x's together, and actually I'm going to do this on purpose. I want to move the 5x over here, and I'm going to get x squared minus 4x equal to 0. Okay, so it turns out what somebody found out was that if you've got polynomials and you're wanting to solve them, one way to do it is to not get x by itself, but instead get it equal to 0 and rewrite it so that you have things multiplying together equal to 0. So what you're going to do is you're going to learn that you can factor out this x here, leaving behind an x minus 4. And when you have two things multiplying together, so you have this multiplying with this and it's equal to 0, one of these things has to be 0 in order for it to equal 0. So what we can do is we can write two equations. We can say, well, x could equal 0 and x minus 4 could equal 0. Those could both be 0 and get this to work out. And sure enough, we've got one of our answers already, and our other answer we get by adding the 4 over. And we've solved it. So it's a way, and you can double check too. You can double check and see that those work. But yeah, so factoring helps us to solve equations that we normally wouldn't be able to solve. So that's one of the biggest reasons why we're doing factoring. Also in Algebra 2, you're going to simplify fraction expressions. And so finding the factoring is going to be involved with that as well. So this is a skill that's going to be really useful in the rest of your career in algebra. All right, so to get there though, let's first focus on finding the GCF, the greatest number that is a factor of two or more other numbers, the greatest common factor. Okay, so how we're going to go about this is what we're going to do is we're going to make a list of factors of numbers, and then we're going to see which ones they have in common. And then the greatest number will be our greatest common factor. So let's try this out. So 45. So numbers that go into 45 would be, well, I guess 5 goes into it. And because 5 goes into it, 5 times 9. So 9 goes into it. And then I'm kind of stuck, but, 9 breaks down into 3 times 3. So I know 3, if 3 divides into 9, it's also got to divide into 45. So 3 goes into it. And I believe 3 times 15 equals 45. And we're about spent there. But we can't forget, which I did. I'm going to admit I did forget about this first hour. I'm kind of embarrassed about it. But what we could also say is 1 goes into 45 nicely, and 45 goes into 45 nicely. And it is important to remember that. Okay, on the flip side, we got 20, and 5 goes into 20 4 times. 2 goes into that, so 2 and 10, and then also 1 and 20. And so we're looking now for the common factors. And it looks like the only common factor they had was 5, which in turn makes it the greatest common factor is 5. All right, let's try another one if you don't mind. Let's go to 12 and 36. 12, let's see, 2 and 6. 3 and 4, 1 and 12. 36, 6 and 6, but we don't have to write it twice. 6 and 6, also, 2 and 18. 9 goes 9 and 4, and I think that's about it. But we also have 1 and 36. Okay, I think I got that all figured out there. I think we're good. Okay, so I did forget one. I'm just now seeing it because 6 has a 3 and a 2, so we could do 3 and 12. And I'm glad I did that because check it out. We have a lot of common factors, but our greatest common factor is 12. It's the biggest number that divides into both 12 and 36. All right, on this next one, we are looking at 3 different numbers. Now I have to ask, do you think you could have come up with these greatest common factors without making the lists? Could you have looked at 45 and 20 and realized 5 was the best number to divide into both of them? Could you have looked at 12 and 36 and said, oh yeah, 12 goes into both of them? Well, let's try that with these here. So to be the greatest common factor of 3 things, it's got to divide cleanly, got to be the biggest number that divides cleanly into all 3 of them. And 16 has quite a few factors, 12 has quite a few factors, but 14 doesn't have very many factors. 14 only has 7 and 2, and of course 1 and 14. But I know 14 won't divide into all these. And I know 7 won't divide into all of these. So this one has a 2. I'm pretty sure our greatest common factor is 2. And I'm pretty sure some of you could have figured that out as well. So I'm just going to kind of leave it there. For example 1, we are now looking at polynomials, and we're going to factor out the greatest common factor from a polynomial. And how we do that is we do it just like we did above. We ask ourselves, what's the factors of 2, what's the factors of 12, and we're going to take out the greatest common factor. And I think this one's pretty straightforward. I think people can see that 2 goes into both of those. So we write the 2 out front. And what we're going to do is we're going to reverse distribute. We're going to reverse distribute. We're going to take that 2 out, and we're going to think, well, what would be left over when we undo the distribution of the 2? And one way to figure that out is you can just divide each term by 2 to find out what should go there. And you can double check yourself to distribute it back. You get 2x plus 12. All right, so the greatest common factor of 6x squared plus 24. I'm pretty certain, we could make a list if we needed to, but I'm pretty certain it's 6. Yeah, 6 goes into 24 4 times. So we're gonna take out a 6, and then we divide to find out what's left. Like so. All right, and then on the next one, 8 and 36. I'm tempted to think it's 8, but then I can check in my calculator and find out, no, 8 doesn't go into 36 cleanly. So 2 definitely goes into both, but I think 4 is the best option, the greatest common factor. Now, it turns out that's not the whole story. Yes, we are going to take a 4 out. But notice, up till now, only one of our terms had an x value, but this one has both terms have an x value in common. Well, guess what? That is a common factor. So not only can we take a 4 out from both, we can also take an x out from both because they have the x's in common. And then just like before, we can divide. 8x divided by 4x is 2. 36xy divided by 4x is 9y, because the x's divide out to make 1. And then 1 times 9 is 9, and then it's gone. All right, so let's try this next one. It's getting more and more complicated. On this one, we have a leading coefficient that's negative, and it turns out whenever that happens, we're always going to want to factor the negative out. So let's write that down first. When the leading coefficient is negative, factor out a negative. Okay, and that's just common what we do. So let's take a look here. Everybody does it, and then everybody can be consistent about seeing, what's left. So immediately when we see a negative out front, I want you to go ahead and write the negative. We're going to take that out. Then we got to think of the greatest common factor of 4, 34, and 16. And I'm tempted to think it's 4, but 4 doesn't go into 34 nicely. So, but they are all even. So we're going to take out a -2. And then notice they all have an x in common. So we're going to take out an x as well. And then be careful when you write what's left. You're dividing. So -4 divided by -2 is 2. And then if you have x cubed and you divide by x, there's going to be x squared left over. -34 divided by -2 is 17x. And then finally, 16 divided by -2x, that's going to be -8. Why? Because the x's divide out. So there's a couple ways to think about it when you're trying to find out what the exponents are left over. One way to think about it is to put a 1 there and subtract, because whenever you divide, you're subtracting the exponents. 3 minus 1 is 2. 2 minus 1 is 1. X and x, if you subtracted the exponents, you get x to 0, which is 1. It's gone. 1 times 8 is 8. So there's a couple ways to think about that. Okay, so what I would like to do is, before I let you go, I would like to look at our practice sheet. Take a look at that. There's lots of practice here for you to get used to factoring out a monomial. And I want to look at one that looks a little bit gnarly. Let's see. Let's look at 24. Looks pretty gnarly. Let's do 24 together, and then we'll cut our lesson short. Or we'll stop it at that point, I should say. So we've got 30 x to the 6th, y to the 5th, 50 x to the 5th y, plus 20 x squared y. So our greatest common factor, looking at our coefficients, appears to be, and I think most of you can see this, I think it's 10. I don't have to take a negative out because there's no negative out front. But then look at your variables. X to the 6th, x to the 5th, x squared. It turns out we can take not just an x from every one of them, but every one of them has enough x's that we can take out an x squared. Every one of them has an x squared. Every one of them has a single y. And then we divide to see what's left over. So we'll have a 3x to the 4th, y to the 4th, 5 5 minus 2 is 3. X to the third, no y, plus 2. The x squareds divide out, the y's divide out, they make 1, multiply by 2, it's 2. And class, that is how it's done. Have a good day.